Okay, let's talk about AGI, Artificial General Intelligence. It seems like it's all anyone can talk about these days. But what is it, really? Today we're going to cut through all that hype. We're going to unpack what might be fundamentally wrong with how we even think about AGI, and explore a much more powerful goal for the future of AI.
Right now, the whole conversation around AI is just completely polarized. You've got the doomers on one side, picturing a future of mass unemployment, maybe even artificial overlords. And then on the other side, you have the utopians who are expecting AI to solve everything: hunger, suffering, you name it. And right in the middle of this huge debate is this one single concept: AGI.
And, here's the real problem. Everybody, from tech CEOs to activists, is throwing this term around, but almost nobody stops to define it precisely. It seems like everyone has their own pet definition, and all this ambiguity is making the entire conversation way more chaotic than it needs to be.
So what this all comes down to is that this messy, super polarized debate isn't just about the tech itself. It's about the words we're using. This vague idea of AGI, this undefined goal that everyone's either racing towards or running away from, is what's really muddying the waters.
So to really clear things up, we've got to look at the very foundation of the term AGI, and that means unpacking that big letter G for general. The default assumption is that we're trying to build an AI that can do everything a human can do, right? We're using our own intelligence as the blueprint for generality. But what if that whole idea is just wrong?
So let's just stop and ask ourselves a pretty provocative question. Are we humans really that general? I mean, it sure feels like we are. But the research we're looking at today argues that this is basically an illusion. We have our own massive blind spots. What we call general intelligence is often just a set of skills that happen to be important for our own species survival.
And this is perfectly illustrated by something called Moravec's paradox. It's fascinating. The things that feel completely effortless to us, walking across a room, recognizing a friend's face, these are things we evolved over millions of years to do, and they are incredibly hard for computers. But the stuff we find brutally difficult, like playing chess at a world-class level or doing insane calculations, well, for a computer, that's actually pretty easy. It shows our intelligence isn't some do-anything magic. It's highly, highly specialized.
And this quote just nails it. Think about the greatest human chess player, Magnus Carlsen. We see him as an absolute genius, but if you compare him to the best chess computers, honestly, it's not even a contest. Our whole perspective is warped by our own limitations. He's a genius compared to other humans. But by any objective, raw, computational metric, what he's doing is something our brains just aren't built for. We're specialized creatures, through and through.
Okay, so if the very idea of human generality is a myth, what does that mean for our quest to build an artificial general intelligence? Well, it means our target might be completely off. Let's dig into why this fundamental flaw makes most current AGI definitions a pretty terrible guide for the future. Just look at this chart from the research paper. It shows just how all over the place the definitions for AGI are. They're mapped out here on two axes. The vertical one shows what the AI can do, from just learning stuff to actually performing tasks. The horizontal one shows the scope of what it can do, from literally anything you can imagine to just the stuff humans do. And as you can see, the definitions are scattered everywhere. It's a complete mess.
Now, the paper points out that for any goal in science to actually be useful, it needs to meet three pretty simple criteria. First, it has to be possible, right? Feasible. Second, it can't contradict itself, so it needs to be internally consistent. And finally, you have to be able to actually measure your progress. It needs to be accessible.
And when you hold the popular AGI definitions up to these standards, well, they just fall apart. If you define AGI as matching human abilities, that's not consistent. Because as we just saw, humans aren't really general. If you defined it as being able to do anything in any environment, that's not feasible. That would take infinite resources. And if you defined it as outperforming us at valuable work, that's not accessible, because that list of valuable work is changing all the time.
So, if AGI is a flawed North Star, what should we be aiming for instead? The paper proposes a totally new goal, one that's way more practical, way more powerful, and avoids all these traps of generality. They call it Superhuman Adaptable Intelligence, or SAI.
So here it is. The key phrases to really zero in on are adapting to exceed humans and tackling useful tasks outside the human domain. The goal here isn't to just copy what we can do. It's to build systems that can learn to blow past our abilities on important tasks and even solve problems we are fundamentally incapable of touching. It's a huge shift from imitation to transcendence.
And here's the best part. Unlike the super vague goal of AGI,
SAI comes with a clear, practical way to measure it. And that, right there, is a game changer. It's not about ticking off some list of human-like skills. It's measured by the speed of adaptation. How fast can a system learn a new task and become superhuman at it? That is a real engineering goal you can actually build towards.
So this is the big pivot. This is the crucial shift in thinking. We're moving away from this fuzzy dream of building a single general AI that just copies us. Instead, we're focusing on a measurable goal, building systems that can rapidly adapt to become superhuman specialists at any task that actually matters. This isn't about building one magic machine, it's about building an incredible toolkit. But hold on, isn't specialization a bit of a letdown? A step back from that grand vision of a machine that thinks like us? Well, the paper argues it's the exact opposite. Embracing specialization is actually the most powerful way forward. Let's break down why.
At the very heart of this is a core concept in computer science called the no free lunch theorem. It's a mathematical proof that basically says there is no single master algorithm that's the best at solving every single problem. To put it simply, to get really, really good at one thing, an algorithm has to give up being good at something else. One size fits all just doesn't fly.
And this isn't just about code either. Specialization is a fundamental rule in almost every complex system we see. In biology, organisms specialize to thrive in their environment. In markets, focused companies almost always outperform the ones that try to do a little bit of everything. And in machine learning itself, if you try to make one model learn too many different things, it can actually get worse at all of them.
This Venn diagram really shows the idea perfectly. We shouldn't think of human and AI intelligence as fighting over the same territory. They're complementary. Sure, there's some overlap where we can do similar things, but the really exciting part is that huge, separate domain of AI-exclusive tasks, things that are completely beyond what a human mind can do. Specialized AIs can fill in our gaps and take on problems we can't even begin to solve.
So, here it is, the single most important takeaway. The one thing to remember from all of this is this killer line. The AI that solves the unbelievably complex challenge of protein folding should not be the same AI that folds our laundry. We don't need one single jack-of-all-trades AI. We need an army of powerful, focused specialists.
By shifting our goal away from mimicking our own kind of limited intelligence and towards creating a world of rapidly adaptable, superhuman specialists, the whole conversation changes. The question is no longer, when are we going to get AGI? Instead, it becomes, what incredible problems are these focused AIs going to solve that we, with our very specialized human minds, haven't even thought to ask yet?